All right, so we're going to take a look at systems of equations together, and we're talking about solving systems using a method called equal values method, and we can solve these systems in a couple different ways. The first way is we can make tables and see when they're exactly equal. Then we can use equations and we can solve them and set them equal to each other, which we're going to do. And the third way is to graph them, which we will also do. So let's take a look at the question. It says, two companies offer different rental packages for personal watercraft jet skis. The first company, Wet Skis, requires a deposit of $135 and charges $50 per day. So Wet Skis requires a deposit of $135 and $50 per day. So down here in the table, I'm going to go ahead and write the equation that represents that. So our equation is always in the form of y equals, and if it's $50 for every day, it would be 50 times x plus the deposit of $135. The second company, Better Jetter, requires a deposit of $285 and $25 per day. So let's look at Better Jetter in the equation. Think you can write it on your own? Use the previous equation to help you. So again, we're starting with y equals, this one's $25 per day, and we're starting out with $285. So you can see that I already started filling in the tables. You can do that as well. I don't think we're going to need 7 and 8, so I'm just going to go to 6 for now. And let's take a look at the first table for Wet Skis. If I don't rent it for any days, I need to reserve it, and that deposit is $135. Okay? So at 0 days, it's going to cost me $135 for that deposit. And then each day after that, it's going to increase by $50. Okay? So on the next day, it's going to be $185. I could use the equation also. So I could plug 2 in for x, and 50 times 2 is 100, plus 135 would give me 235. But because our x values are increasing each time here by 1, we're just going to be adding 50 each time. Okay? So 3 would be 285. 4 would be 335. 5 would be 385. And 6 would be 435. Okay, we're going to do the same thing for the other table. And same thing. Our deposit's $285. So I need to put that down before I can rent for a day. And then each day this time is only going to increase by 25. So going across the table, we're just going to be adding 25 each time. So for one day, it'll be $285 plus 25, which is $310. For 2 days, $335. 3 days, $360. 4 days, $385. Again, I'm adding 25 each time. 5 days would be $410, and 6 days would be $435. Okay? So I'm hoping that you're looking at these tables right now and you're like, oh, I know when they're going to be equal to each other. They're going to be equal to each other at 6 days. At 6 days, it's going to cost me $435 if I rent from Wet Skis. And at 6 days, it's also going to cost me $435 if I rent from Better Jetter. So it doesn't matter. If I'm renting for 6 days, it doesn't matter which company I go with. But if I'm renting for less than 6 days, which company is going to be the better one to go with? I'm hoping you're saying Wet Skis because all of their values are a lot less for 1 through 5 days. So what's going to happen for 7 days? Well, for 7 days, it's going to switch, and Better Jetter is going to be the better deal. So at 6 days, it doesn't matter who I rent from. Less than 6 days, it's cheaper with Wet Skis, and more than 6 days, it would be cheaper with Better Jetter. Okay, So I said we could use those equations and we could set them equal to each other and find that same information. So the equation we had for wet skis was y equals 50x plus 135. And the equation we had for better jetter was y equals 25x plus 285. So because they're both equal to y, I can take the portion that is equal to y and I can set them equal to each other. So 50x plus 135 equals 25x plus 285. And I can solve this equation for x, and that'll tell me how many days I can rent for, and they're going to cost the same amount. So from our tables above, we know we should get 6, but let's see if we do. My first step is going to be to get rid of this 25x, which means I need to subtract it on both sides. 50 minus 25 gives me 25x plus 135, and that equals 285. I'm going to run into the next question, that's fine. I'm going to subtract 135 now. I'm going to be left with 25x equals 150. And hopefully we know that when we divide 150 by 25, we get 6. So for 6 days, they're going to cost the same amount. So how would you find out how much? You would put that 6 back in for x in either equation. Okay? So C, it says, which is a better deal? Y, explain. So we said earlier, it depends on the amount of time that you are renting for, right? So if we are renting for less than 6 days, Wet Skis is the cheaper company. If you rent for 6 days, either company will work because they will be the same price. And it will be cheaper to go with better jetter if you want to rent for more than 6 days. Okay, so hopefully that makes sense. And the last thing we're going to do is graph. So I'm going to move down to this graph paper, and we need to figure out how the heck we're going to scale this graph paper. So I think I would start on the x-axis. That's going to be my days. And I think we can just do by ones. So, because we're only graphing 6 days. All right. And on the y-axis, our lowest value is 135 and our highest value is 435. So sometimes when we're graphing, we can use this little symbol. I'm going to draw it and then you can see it. Whoops, not that symbol. Okay, so see that little squiggly line I put down there above 0? That's called a broken axis, and that allows me to start at whatever value I want. So it's saying that 0's there, but I skipped a bunch of values between 0 and my first value, okay? And so our first value that we're graphing is 135. So that's what I'm going to put on this line, the first line. And then I'm going to figure out what I should count by. So 135, and I need to go to 435. I'd like to go a little bit above that. So if we did 50s, would that work? I think we can count by 50s. And I'm not even going to count every 50, I don't think. Well, I guess I can. 185, 235, 285, 335. So it happens to match the wet ski numbers exactly, which means it's going to be a little off and we'll have to go in between for better jetter, but that's fine. Okay, so that fills the axis. And I don't remember what colors I used above, so I'm going to go back up. Looks like wet skis I did in purple, so I'm going to plot those points in purple and make my line in purple. Okay, and let's see, maybe a thicker point. Okay, so this one's going to be a little bit easier to graph because they're going to be exact values on the grid. So at 0, it's going to be 135. 1, it's going to be 185. 2, okay, up to 6. If I wanted to do 7, it's going to follow that same pattern. Okay, so now connecting them. Okay, my line looks like that. I'm going to go back up and see, I made that one like a pinkish red. Okay, so we'll go with this color. And it's going to be 0 to 85, 1, 310. So this is where it's going to become tricky. So 310 is not quite up to 335, so I'm just going to put it in the middle there. 2, 335, 3, 360, 4 was 385, 5 was 410, and 6 was 435. So maybe I'm going to go back and those ones that don't intersect the grid right away, I'm going to just get rid of those and I'm going to plot the ones that are exact values. Just makes my line a little bit straighter. Okay. So that's where our graphs look the same. And now you can see that on the graph, this point of intersection is at 6 days, $435. So there's 3 ways to solve this type of equation. 1, make a table. Sometimes that can be cumbersome because you may have had to gone further than 6 values in your table. 2, you could use the equations to solve, or 3, you could graph the equations. So there are some questions for you to continue on this packet. The whole thing should be complete, and when it's all complete, please turn it in. Have a great day.